Today we're going to observe patterns in nature. These patterns don't just exist by accident. There's actual structure to the patterns you see around you. Have you ever counted the number of petals in a flower? Given the variety of flowers in the world, you might think that any number of petals is possible. But it turns out that some flowers have 3 petals, most have 5 petals. And if it isn't 3 or 5, then they seem to favor numbers like 8, 13, or 21. Do you notice the connection between these numbers? You get each number by adding the previous 2 numbers together. For example, 5 plus 8 gives you 13 and 8 plus 13 gives you 21. This right here is the most fascinating pattern mathematicians have ever discovered. Before we begin this lesson, I want you to notice the patterns in the space around you. How many do you see? Many, I'm sure. Now, let's look at patterns in math. We know 2 raised to 3 is equal to 2 multiplied by itself 3 times. 2 raised to 2 is multiplied by itself 2 times, and 2 raised to 1 is 2. If you notice carefully, there is a pattern being formed here. To go from 2 raised to 3 to 2 raised to 2, we will have to divide by 2. Similarly, we divide by 2 to go from 2 raised to 2 to 2 raised to 1. Let's use this pattern to find out what 2 raised to 0 is. According to the pattern we just defined, every time we decrease the exponent of 2 by 1, we need to divide it by 2. So, to go from 2 raised to 1 to 2 raised to 0, we will divide by 2. Let's do that. If we divide 2 raised to 1, which is just 2, by 2, we get 1. This makes 2 raised to 0, 1. Now, let's continue this pattern further by reducing the exponent of 2 by 1 again. This will give us 2 raised to negative 1. According to the pattern, this should be equal to 2 raised to 0 divided by 2, or 1 over 2, or 1 over 2 raised to 1. I think you already got the pattern, but let's do this one more time. Let's reduce the exponent by 1 again to have 2 raised to negative 2, which should equal to 1 over 2 divided by 2, or 1 over 2 raised to 2. Similarly, 2 raised to negative 3 gives us 1 over 2 raised to 3. Do you see a pattern forming? If we generalize this pattern, we can conclude that any integer x raised to the exponent negative m is equal to 1 over that x raised to the exponent m. If you noticed, we changed the negative to positive and multiplication to division. Therefore, we can say that an integer raised to negative exponent is the multiplicative inverse of the corresponding positive exponent. This is called the negative exponents law. See how patterns can be useful in math too?